nomenclature. Again, the notes are online. They're very straightforward. If you want, you can be writing definitely though in your notebook as well, but that's how notes will start being sent out. If you want to do them on Notability, that's absolutely fantastic. If not, definitely in your notebook, we'll try to, you can print it out early if you'd like. That was Crisscross. I heard not all of us got the pleasure of listening to the Lyrical Geniuses on Monday. They're like two 10-year-old kids when I was like 10 years old. And crisscross, that's what we're doing. We are crisscrossing. So we will be having a steady diet of crisscross. Either jump, warm it up Chris, which is now what Chris Bryant, the reigning National League MVP, goes out to when he comes out to his at bat. He goes out to warm it up Chris. And then the horribly named and sung "I Missed the Bus." They're 10 years old, they got to talk about what they know. They missed the bus. Something that they'll never ever do again. Okay, so tomorrow, nomenclature 1 is due. Tomorrow is simply a work day. We will be in class. We will be helping you. If you have questions, that's absolutely fantastic. We'll work with you on those. But I want to start off with some questions from nomenclature 1. So I have a few first that I just want to make sure I can compare with from one to the other. If you have some other questions, I can definitely do 3 or 4 of them for you. Then we'll get into another layer of the nomenclature. And then I have a really funny video that we got to watch last hour that hopefully you find this really exciting. So 94 versus 92. Don't know why I did the 94 first versus the 92. Reminder, there is an issue right now with knowing if you're supposed to be using what we did on Monday. Are we using prefixes? Or are we just doing charges? So we do have to tell you a lot right now about, hey, you're doing prefixes or you're doing charges. So if you ever see the word ionic above, you are crisscrossing the group. You're doing charges. Later we're going to tell you that the big tip would be it's a metal and a non-metal, so you're using charges. But you can either use charges or prefixes. You can't use both. So we are not using any prefixes today. We're all about crisscrossing. But how do they both work? Full name for the first one, right? The first element. The second element, take the word, drop the ending, add IDE, right? So when I see this PT and O, that is platinum. We take the ending of oxygen. You will have to get familiar. There are different endings, or they're all the same, but how you drop it off, like it's not oxygenide, it's oxide, it's phosphide, it's nitride. You'll get used to it. But this is oxide. Here is the question, and I'm just going to put it right here. I don't know if you're going to need it. At the ending, which gives a lot of people frustrations, is there supposed to be parentheses with the Roman numerals? And what the heck is a Roman numeral in this case? So we'll talk about that in a moment. This one, strontium. Again, I'm not sure. And then my favorite of all the anions for ending, iodine becomes iodide. Just sounds weird. So let's quickly review what the Roman numerals mean. It is the charge, bless you, of the metal. The metal is always the first one. Why do I need to use it sometimes and not others? As a review, this entire column is always +1. So if I pull a metal from the first column, I never have to tell you that it's +1 because it's always +1. This one's always +2. Oh, right there. This one's always +2. So that would not have any Roman numeral. So if you're ever in doubt, you can always leave a blank. Please do not follow suit thinking that I should always put a parenthesis with a question mark. I'm just giving you an idea. Like, you could leave a small space. I don't need it. Oh shoot, of course it's not separated. I don't need it like way over here. Leave a little space. But why and when do I need those? If they're transition metals, or if they're SN and PB. Now there are more than that, but that's what we're going to hold you to. This is not a very scientific way of remembering, but your first gut feeling should honestly be is if you've heard about that metal before you came into chemistry. Not a lot of people going around the street going, strontium, favorite alkaline earth metal. Like that's just not something you do, right? Oh yes, rubidium. Now that is a reactive metal. Like you don't think of metals, but platinum, copper, zinc, iron, tin, lead, those are metals. You know, you've heard of them. So if you have, you probably need a Roman numeral. So we do, you need a Roman numeral. And what that does is it tells us the charge. I'm doing this one on purpose. There's nothing written down here. So yesterday, what am I trying to say? On Monday, we have to went over the fact that you got to use the second one to be able to figure out the first. The second anion, the second atom is always known as a charge. I always know that charge. Oxygen, if you're thinking that's -3, let's try to buck that right now by remembering that the noble gases are always 0. So then this is -1, -2. So this is 2 minus. These are equal. They're not necessarily 1. They're equal. They're 1 to 1. So if this is a -2, this has to be +2. This is -3, that has to be +3. This is -1, that has to be +1. So I write a 2 because that's the charge of that. Why don't I need a charge for that one? Because it's always 2. So do a little quick comparing and contrasting. When there's numbers, I like it. Why? Because we can reverse cross. You take that 2, you bring it up. You take that 3, you bring it up. And no matter what, this is nickel. Something oxide. Again, nickel. I've heard of nickel. Oh, look. It's in the transition metals. I need a Roman numeral. So is it nickel 2 or is it nickel 3? It's 3 because it's the charge, not the number. It's not how many. If it's how many, I could look at it and be done. The charge is a little extra effort. It's a 3. And just so you have a clear understanding of what this truly means, is I have 2 nickels and I have 3 oxygens. Each oxygen, memorize oxygens 2 minus. It'll just make your life that much easier. That's the one that shows up the most because things react with oxygen the easiest because it's in our air. There's 2 minuses all the way through, so it should also kind of make sense in this kind of an illustration that those would be 3 pluses because 3 plus 3 is 6, 2 plus 2 plus 2 is 6. I need even negatives and positives. But crisscrossing can help me with that, besides getting down to the funky beats. I was telling my class, when I was in junior high and kind of middle school, we couldn't get into school until like 5 minutes, like they just keep us outside even in the winter. And when this song came out, there'd be like 400 of us huddled around in front of school. We'd all be jumping to that song. Like it was a good song. It was a good time. All right, any other questions? Yeah. Yeah. How many times have you said, please do number 82? So this is weird, and actually it's funny you bring this up because later on I'm going to have one similar. No matter what, you should be thinking full name, drop the ending at IE. So this is copper sulfide. Like, regardless, right? The only thing in the back of your mind should be, do I need a Roman numeral or not? In copper, I've heard of copper, right? Oh, yeah, it's in the transition metals. So Jane's question was, why is it a 1 instead of a 2? It has nothing to do with this 2. This is what's really weird. I'll even write this. I wonder if I have that next to it. Of course I don't. If I reverse cross, that 2 makes sense with that S. It has to make sense, though. S is -2. So if that 2 is there, if nothing's here, what is that? It's a 1. It's not a 0, please. If it were a 0, we wouldn't write it. What a weird thing if we just wrote stuff and then like 0, 0. Like it wouldn't be there. So this would be a 1. What's weird about this, so this is copper 1. This is copper, they're equal. So sulfur is 2 minus, so this is copper 2 sulfide. I think that's bizarre to see, wait a minute, the one that's 1 is 2, and the one that has 2 is 1? It's because of the charges. It's because of the charges. So you needed 2 coppers to offset that 1 sulfur. That's why there's 2 of them. Okay? And in this one, you would need 1 of these to offset the other one of those. So I know it's weird, but reverse cross, and you'll get the charge. Anything else on any sheet? Up to 3 we had to go. Yeah, Karen.
Number 83.
Silver oxide. Okay, so no. What are the 2 elements that we have to have memorized for their charges? Remember and tell me what they are. Silver and zinc. The reason why, what is this one? Silver oxide? I can't remember already. What number?
83.
Thank you. There we go. I got it. This is what's hard. It doesn't have any, like, where the heck is my Roman numeral? And you're like, well, I don't need one. Yeah, I do, because it's not in the normal column. So that's where they won't give it to you because silver is always the same. So we try to remember it's not the reason because of it, but silver is in group 11, so that it ends in 1. It's not true for the rest of them in this group, but it ends in 1, so that's a +1. And zinc, I have it half covered, unfortunately. That's in group 12. It ends in a 2. Those two you will not be given Roman numerals because they just don't give it to them. Because if it's always the same charge, you don't need a Roman numeral. So to do this, you would need to know that. So it'd be AG, it'd be O. Hopefully you can even see that. This is a 2, right? This is a 1, so it becomes AG2O. So you do have to know the silver and the zinc. And you learn that on Monday. If you didn't remember those charges, then there you go. Okay. Right. If you have some more questions, we can definitely answer them. We are still working on it tomorrow, potentially. I know some people are starting to hand it in already. I hope you have found that it does go a lot faster than it first looked. And if it's not, it will start to speed up. We need to add a new layer, so either you're going to be doing your notes, we don't have a lot of them, on your iPads, or let's get our notebook, please. You will want these. I'm teaching this all through just examples. I do not believe in a lot of laws and rules, and if there is one, I can label it on an example, just as easily as writing paragraphs. Let's get this all together. Polyatomic ions. I hope you all have a sheet. Does everybody have one? Else I can get you one that you walked in with. Should have. I want you to have that out. You should have a periodic table with a bunch of stuff on the other side of it. Poly means many. If you were in math and you were doing a polygon, you don't have a set number of sides. It's just many-sided shape. Atomic is just atom. So polyatomic means many atom ion. So you have multiple atoms in one. There will be certain ones you will have to memorize. We have told you already on your sheet. But I'll teach you today how to figure it out without having to memorize it. So, first two examples kind of show what's happening here. You got sodium sulfide and you got sodium sulfate. And I hope, I don't think it's a big leap, to see that's my difference, right? One ends in an I, one ends in an A. Let's really try to be clear on where we need to be looking and how we handle this. This is what we learned on Monday. Full name, drop the ending at IDE. So this is probably an atom. From the periodic table. If it ends in 8 or 8, that's going to trigger what we're going to learn today, which is a polyatomic ion. So if you have an 8 or an 8, polyatomic ion. Most of them you'll be able to use a sheet for. I mean, all of them right now. But you'll have a reference. And you just look it up. And you truly just take the letters and the numbers and the charge, and you just throw it on the paper, and we're going to do exactly what we did on Monday with our crossing, our charges. And that's why crisscross is just so vital to chemistry. The group, not the action. Okay. So, starting with this first one, I have, simply put, I have sodium here, I have sulfur here. A lot of you, we're going to start pushing you into writing this once and never having to clean it up. But I'm going to show you what I mean by cleaning it up and having a nice final answer. If you're still in the beginning doing this, that is perfectly fine. I need to write charges down. So sodium is in my first group. Every time I see you do this, you should be agreeing with my charges. If not, we need to talk about this. This is all group 1, so this is +1, +2, +3. So sodium is +1. Sulfur is -1, -2. So sulfur is the -2. And then I need to just crisscross. None of that can be in my actual final answer. That's great, but that's not it. Even if, oh yeah, we'll write the 2 down, it's fine. No, I need a final answer that's clean. And we don't write ones, you just don't. If you do, it's fine. You don't get it marked wrong, but it's not the way you do it. It's just, you don't write a 1. So that's just Na2S. Not much more to it. It's different. This is sodium sulfate. So, I know I have a sodium. Now let me tell you right away, all polyatomic ions have a letter, an element, and then for the ones we're learning, a certain number of oxygens. So right away, and you're going to get used to this, it's got to be SO something. I just don't know this part, don't put these question marks, or that part. But I can look, I'll come back, on my polyatomic ion sheet. So if you don't have that out, and not on the periodic table side, the other side, actually let me address this for one moment, because some of you are going to do this, and that's fine, but hopefully you'll do it the way that we're requesting you. You have a nice periodic table, you might have other ones too. There's no problem in you writing, don't do it yet, +1, +2, +3, -1, -2, -3, but you can't use that as a crutch. If you write that in pen or really dark, and every time you look at your periodic table, you look at that number without realizing, oh, it's just each one, you're not going to get any better at this, and then you're not going to be able to use your periodic table anyway. So if you need to do it, like you hear a voice, write the numbers. You better write it really lightly with a pencil where you can erase it eventually and be like, oh yeah, I do have that down. Like, understand that I've seen a real negative effect when people don't have that clean on the top for the entire time of doing this. But this is, I'll come back. This is my polyatomic ions, and you can see a bunch of elements, oh my gosh, and charges. We'll talk about which ones you need to know. There's certain stars on them, but it's based on alphabetical order and charge. It's not a real complicated sheet. I'm looking for sulfate. I see S's here. Oh, there's no S's. You don't keep looking like it's in alphabetical order. It's not up here in the C's. So I go to the next set. This is all -1s, -2s, -3s, and just 2 positives. So, oh, here it is, sulfate. And I see it's SO42-. So that's all I need to write down. So these are actual Lewis structures that we did. You have an S in the middle, you bond 4 O's, you needed to add 2 more electrons, it became -2. These are the things we've actually been doing. We're not going to draw them though, we're going to learn how to name them and make the formulas. But now, everything else falls into place. We crisscross, just like before. Right? I need, this is a whole thing, this one thing is -2. So I need 2 NAs for every 1 SO4. So my mind, just so you have maybe an idea of how I'm relating this, I have 2 NAs for every 1 SO42-. The whole thing, SO and 4, has 1 charge of -2. Okay? So same kind of rules. Next one, and below it, I'm actually doing a different problem first. I think comparing and contrasting problems is the best way to see how these all work. I have aluminum nitride. If you're doing the pre-made notes for sure, you can probably squeeze aluminum nitride below it. I'm going to do that one actually first. Why? Because nitride, kind of like the one I just did before, that tells me that's from the periodic table. So that one is a lot more straightforward. I would have aluminum, and I would have nitrogen, and this would be 3+, this would be a 3-. 3+, 1, 2, 3. 3-, -1, -2, -3. So what does a 3+ and a 3- do? Cancel, right? If you crisscross them, it's fine, but you got to still reduce. So that would be just ALN. That would be my final answer for that. It is not okay to leave the charges. So again, push yourself eventually, like, you know what, maybe I'm not going to write them at all. I'm going to say them in my head, I'm going to put the elements down and cross them myself. But this is aluminum nitrite. 8s and 9s. Okay, so what I need to do is I have my aluminum. Okay, again, nitrite, you should be thinking, well, that's probably a nitrogen and then some oxygens. So let's take a look. Here I am. I'd like you to take a moment, and I want you to see this. I don't want me to tell you. You have chlorates and chlorites. You have a nitrate and a nitrite. You have a sulfate and a sulfite. Can you tell me the difference between the 8s and the ites? Between the 2 of them, not all of them together, between each set? What's the difference between the 8 and the ite? Oxygens, isn't it only? Right? Charge same, elements the same. Which one has more? 8s. You ate something, you got bigger. The 8 always has 1 more than the ite. It's part of the suffix. So, nitrite, NO2-. Aluminum, 3+. Okay, this one example is absolutely, it's huge. This shows us a lot. So I'm going to crisscross them. And what is this saying? It's saying that I need, the 1's going to come down here, so I'm going to have 1 Al, right? The 3 is going to come down here, so I need 3 may or may not want to actually write this part, but I'm going to give the actual final thing. I need 3 of those. 3, why? 1, 2, 3 negatives equals the opposite counterpart of the 3 plus. Balance out. Well, how do I do that? How do I put the 3? You know, where does that all go? Well, this is the one rule that you need to know today. Is we need a parenthesis. Every time, if you want to keep this real simple, every time we crisscross to a polyatomic ion, you need a parenthesis. You need a parenthesis when you cross to a polyatomic ion. If you can just remember that. It doesn't matter what polyatomic ion, if you're bringing a number down to it, put it in parentheses. So that's, and this is how I verbally say this. Well, there's 2 ways. I don't like one of them. You can say AL, well, actually there's 3. Some people say AL parenthesis NO2 parenthesis 3. Whew, all right, let's not do that one. Some people say AL NO2 parenthesis 3. But if you say 2 numbers in a row when you're doing naming like this, these parentheses assumed. So a lot of people will just say, if we call on you, you're trying to tell somebody else an answer, ALNO2 3. That's how I would always just tell people. Oh, what did you get? ALNO2 3. If I say 2 numbers in a row, that means that there's probably a parenthesis around one. So that's the only thing we have to think about. So I want to show how we can apply that in some different situations. So I have just a couple more names, and then we'll go the other direction. And you'll notice that certain directions are easier than others. Okay, so ammonium dichromate, awesome substance. We're going to do a demo of this later. It's very dangerous stuff. It's a carcinogen. Very toxic after it is burned. We're going to burn it in the fume hood. It is a very sweet looking reaction. So we'll do that in a couple weeks. Okay, so a couple things to look at. 1, definitely I see an 8. What? I see an 8. So for some of you, you'll spend 2-3 minutes looking at your periodic table and you're like, can't find ammonium. If it doesn't sound like it's an element, or you don't feel like you can find it, then you're looking on the wrong thing. So if you're looking at your polyatomic ion sheet, maybe it's on the periodic table. If you're looking at the periodic table and you can't find it, maybe it's on your polyatomic ion sheet. This has to have a positive charge because it was the first name. You only have 2 options. Ammonium and dimercury. Oh, hopefully that's the one. So ammonium is a polyatomic ion. It's really the only one we're going to use for the positive ions. If you've heard of ammonia, it's very close. Ammonia is NH3. This is NH4 plus. Dichromate. It's an 8. So you find it. I bet there's 2 CRs in it because it says dichromate. So if you look it up, it's CrO7 2 minus. Directly from my polyatomic ions. It suggests that you see these. So that you're like, oh, there it is. No need to memorize. There's not one part of that dichromate ion that you have to have memorized. What do? We have to crisscross. So this problem, why I have this up, I hope this will register. Okay, sorry. All of these numbers, none of those, it's not your job to change one of those values. Your job is to simply crisscross. That's it. You don't change a single subscript. Your job is to take these and just crisscross them. So if I bring a number down to a polyatomic ion, I need a parenthesis. So I just take the ammonium completely as is. I'm going to take that number, I'm going to put it down there. You bring a 1 down to something else, nothing happens at all. It's a 1. So that would become NH4 2Cr2O7. And wow, there's a lot of stuff there. Your job was to get the 2 ions down and crisscross them. I have one more word, or name going to formula. So what I'd like you to do, before I let you loose, I'm going to get you a good head start, but I'd like you to try to do this without me. So before I let you do that, I do want to just discuss something that's going to just kind of screw you up. Periodic table. You'll be looking for a while, because I don't know what element you're looking for, but I don't know if the hydrogen oxide, or hydrogen oxygen molecule, or the hydrooxygen molecule is that would be written. Doesn't quite sound right. Sounds like a combination. If you're not sure, look at the polyatomic ion sheet. So here's my hint to you. But all you need to do is find those two ions, crisscross them. Okay? So maybe one's from the periodic table, but maybe not both. So take a look at your polyatomic ions. Think about the charges on the periodic table. Do your crisscross. I'd like to see what you get. Okay? Just be honest, very, very upfront. The last 6 years, that exact problem's been on the test. That exact magnesium hydroxide. And less than 50% of people get it right. And I do it every year. We do it every year as an exam. So try it. Here we go. We'll get it. Give you about 30 seconds to find all the 7 U's. Look up magnesium, it should have been a 2 plus. If you looked up hydroxide, it should have been a 1 minus. You think crisscross, and I'm going to guess, and most of you wrote that. That's my guess. This is why most people get this one wrong. What is wrong with this? There's no parentheses. But here's the issue. There's nothing here to slap you in the face going, wait a minute, what do I do with a number next to a number? Parenthesis. It's really difficult for that to trigger in your mind. You need 1 mg and you need 2 of these. But what is that saying right now? You have 2 H's and only 1 O. So you stay with the really simple rule of when I cross a number down to a polyatomic ion, I need a parenthesis. And OH is the one that gets people because it doesn't really shout out parenthesis. But if you brought a number down to a polyatomic ion, you need a parenthesis. So if you got that right, good job, because over 50% of people get that one wrong. If you didn't, hopefully it makes sense. And maybe we'll move forward and not ever make that mistake again. All right, we're going to go the other direction. So if you have pre-made notes, it's up in the upper right of the sheet. You don't have to start over from the beginning. It's right there. How do we do names? I think a lot of times the names are a little easier because there's not as much I have to get right. I don't have to get all the charges right. I don't have to get all the elements right. I have to get the names. Okay? I start with this one on purpose. I only see 2 elements. Poly means many. There's 2 elements. So there is no polyatomic ion here at all. So it's just straightforward. Full name, second one, drop the ending, add IDE. So I have barium, which is what you do to a dead dog. One hour I was like, oh my god! I'm like, what? Did you just leave it in the living room? Oh my god! It doesn't. So we had a pet fish beta named Lava that just died this last weekend, and I had my kids' fish, which I'm the one that took care of it all the time. They won it at daycare, which I think someone accidentally bought too many and just gave it to my kids. And it died, and they all said goodbye to Lava, and they did okay with it. But I didn't have time to take a proper burial, you know. So it's a little tank. I put it out in the garage, and this morning it was frozen, like a cube, but clear, like really clear. Like I'm like, is that even frozen? And somehow, because of the density of the water and the fish changed, Lava was not on the ground anymore. It was halfway. It was in the middle. I did not But there was a moment I was about to run in, kids, lava's alive! Because they're looking like half swimming. But I couldn't have done that to them. Because then they're like, no! Because then it was like half there. He was frozen right in the middle of the tank. I'm like, oh my God, it looks like he's alive again. He came back. But I did stare at him for a second. I also expected him to like blink at me. You know, and be like, you know, he's preserved.
Fish don't have eyes, but you could have just blinked at you.
It makes a better story. You know, when a pie walks into a bar, it doesn't speak either, but there's a lot of jokes. All right, does barium need a transition or a Roman numeral? And I just gave away what I'm thinking about. Is it a transition metal? No. It's in the first two groups, right? So no, so I don't need that, so I move right on. So now I just finish it off. I drop the ending at IDE and it becomes barium phosphide. Why phosphide? Because it's an element from the periodic table. You drop the ending, you add IDE. Okay? But, what about these other ones? So now, there are two things. I see them both, but one should jump out more than the other. This one, first off, 3 elements. Oh, polyatomic ion. Those of you that are going to take this, well, we all take it after a break, but some of you who have not been working hard on this, you'll name this some weird formation of nickel, phosphorus, oxygen, and you'll sprinkle a couple prefixes in there because it'll make you feel better about it all. Some of you will name this one nitrogen, hydrogen, chromium oxide, and you're like, oh, that's got to be right. Even though there are 25 problems on the right side that have names and not one of them has more than 2 words on it, you'll still think, well, 4 of them, I'm going with 4. You got to realize if you're writing more than 2 words, unless if you're knowing that it's kind of a very unique problem, you're writing 2, so you're probably doing a polyatomic ion. The one that jumps out to me, though, parentheses. I see a parenthesis, it's got to be a polyatomic ion. So, I write nickel. Again, I pause for a second and just ask, even if I don't fill it out yet, do I need a Roman numeral? Nickel. I've heard of nickel. I know that's a metal. And if you're thinking, well, that's not a real concrete way of doing it. Nickel's in the transition metals. That's the actual definition of it all. If it's in the transition metals, it has multiple charges. Let's go back to that, though. Then, if you haven't already been noticing some of the trends, this is phosphorus with some O's. It's got to either be phosphate or phosphite. You look at your sheet and you figure it out. It tells you. So this is phosphate. By the way, this is not acceptable on the test. Be like, what? No, it's there. What? You didn't commit. I mean, please go 50-50 and try to get the points. Leaving it blank is not a better solution. So, let me ask you, is this nickel 2 or nickel 3?
2.
Nickel 2 or nickel 3? 2. Because the Roman numeral is the number of atoms or the charge. Check. Well, we're learning today. You do reverse cross, it is the charge. Please understand, it is the charge of that metal. So if I reverse cross that 3 should make sense because phosphate is -3. You can look right on your sheet. Okay. I have 3 more to do, and then we'll talk about how we can memorize these without a lot of rules. You know, I gotta give you a few rules for that. Okay, SrClO22. My favorite attire, strontium. No matter what, it's strontium. So I see ClO2, that's like some sort of a chlorate. I gotta look it up. Does it need a Roman numeral? No, it's group 2. It's not in the transition metal. So I can go right here, and I'm gonna write chlorite. Chlorite. And believe it or not, that's done. There's nothing else to write. The only time I need, I'll keep repeating this because this is the one thing that gets in people's way the most. The only time I need a Roman numeral is if that first metal is a transition metal or Pb or Sn, tin or lead. It's the only time. If it's not, I don't need it. It is wrong if you put it in. If you write strontium Roman numeral 2, it is wrong. Yeah, but it has a 2 charge. It always has a 2 charge. That's why we don't do the Roman numerals. All right. So it gets us to these last two. And Jade, you kind of ruined my thunder on this one, because we did Cu2S already. But let's go anyway. No, it brings up, and your question is the reason why I'm doing this problem. This is really confusing. Why one of these is the answer versus the other one. So let's try to break this down. First I have copper, and then we've already had this one once before, this is sulfate. So both of them would be copper sulfate. But if I have the exact same elements, then you've got to probably assume there's already going to be a transition, or a Roman numeral. Copper, it's element number 29. It's a transition metal. I've heard of copper. Copper is one of the coolest elements, in my opinion, that exists. Like in a mall or in public places, any railing that's made out of copper, I think every place should have only copper railings, because the minute any kind of a germ hits copper, it dies. Copper has a really unique property. Do you know where in a mall is the place that has the most germs on it? I actually shouldn't open this up for you just in case. It's an escalator handle. So like when I'm sitting at the end and it's rotating and I'm just have my tongue out, like it tastes germy. It really does. I don't know about you. Maybe it's just me, but I think it tastes germy. But when I taste the copper railing, I'm like, this is really sanitary. No, but in hospitals, like every doorknob should actually be made out of copper. Now, I don't think like you can like, I don't know if it'll kill Ebola. I mean, I don't. Here are some pennies. Man, I'm feeling a little sick, and just start eating pennies. Like, I think I'm feeling it. But here we go. Bring it back. Let me bring up something really important. Why do I know that this did not happen? I'm drawing it. Don't draw that. Why do I know that 4 did not actually cross down? Because this is what's difficult. Look at all these numbers. Like, wait, before you answer it. Like, look at all these numbers. How do I know what's from where, and was it there beforehand, and everything else? Why do I know that 4 did not result from a cross? Oh, Andrew. Yeah, but how do you know it's part of the original without knowing what the formula looked like? What's a huge hint? Try not to give it away. There's no parenthesis. If this 4 came down, if it had come down, there would have been a parenthesis. Don't draw that on there, because it doesn't exist. But there would have been a parenthesis. So there isn't. So what that means is that it's not that nothing came down. What number came down? A 1. Now technically these things aren't happening. They're not actually sitting there and they're going like here, and they're throwing their charges, and the other guy's like here. It's just they come together like these things that I've been doing. But we use the crisscross as a cheat. So, if this is a 1, this would have been a 2. So what am I writing again? Copper 1 or copper 2? 1. It's not that number, it's that number, right? And this is where at the beginning when Jaden asked, I don't get it. Why is Cu2S, which is exactly the same kind of problem, why is that copper 1? Because it's a 1 charge. So this one, why is this one kind of weird? There's no numbers crossed. Yeah, there's a 4. No, there's a no parenthesis. So whatever this charge was, this charge is going to be. We always use the second ion to figure out the first one. So if I looked it up, I know we just did this problem. If I looked it up, sulfate is -2, so copper must be +2 because there's nothing that crossed. They must be the same. So this becomes copper 2. And it's a bizarre view because why is the 2 the 1 and the 1 the 2? Because it has nothing to do with how many you have. It's the charges, and it can definitely play tricks on your mind. Okay. So, I think that's the little thing. Anyway, is that the last example who's doing pre-made notes on the top part? Okay. All right, we have one more quick thing. I will be very upfront. You may not feel like you have this down 100% the first time, but let me just give you a little public address announcement or service announcement. There you go. I just learned about this like 3 years ago. I had to memorize these through brute force, just like I will memorize. And I made all the students do the same thing. And then the year I figured this out, I taught it to general chem, and the AP kids who had taken it the year before got wind of it, and they're like, why did we not learn this? So they were very upset because they saw how much easier it would have been. So right there, when I heard them say that, I'm like, oh, this is useful. This is really useful. I wish I had this. But I walked up the school both ways when I was a kid. So here we go. If you're not using my sheet, what I have is tricks to memorize polyatomic ions. This is tricks to memorize polyatomic ions, and I'm just doing 2 of them. Sulfate versus sulfide. Okay? And what I can do for you is I can get you to figure out the charge and the number of O's. Now at the ending of the hour today, I'm going to show you a really, I think it's hilarious. I'm assuming she's a professor, but she might just be a lady in a living room. I don't know. Let's assume she's a professor at MIT. She gives this really hilarious way of memorizing. I don't even want to spoil it for you. We'll just get into it. So here we go. If I say sulfate, there has to be something that you know. You have to be able to say that that's SO, something, okay? When I say chloride, you have to be able to say that's ClO, something. So what our job is now is what's the charge, don't draw that right now, and then how many O's. That's what I can do for you, okay? I feel like I'm selling you, kind of. What group, literal group, is S in? Group. Like, I'm sorry, number. Sorry, I should say 6. Or 16, right? 6A or 16, right? I'm going to write 16 just because that's technically the number, but 6A is really it. That's even. This is in group 17, right? That's odd. Oxygen's always going to be there, so I don't even have to look at it. Now, this doesn't completely work because if you have phosphate, it's 3 minus. But for all the other ones, this works. Just about. If it's an even charge, it's a 2. If it's an odd charge, it's a 1. You got to do that first. If you have the charge down, the next part then works. So that's charge. So you're going to use the groups. Now this is the part, if you don't quite get it the first time, you just need to do it a few times and it will work. It's all about 8s. Just stay with me on this. So this is an 8. Let's just focus on that one. 2 is greater than 1. So 4 is greater than 3. Those are my numbers. So if I have a -2 and it's an 8, I automatically have 4. Here's my rules. Okay? If that's the case, I'm done. What if this was sulfite? It's not SO4 2 minus, it's SO3, right? Don't 8s have 1 more than ites? Okay, so you just got to remember why 8's something. I got larger. So an ite would have 1 less. So if 8s have 4 minus 2, ites would have 3. Actually, I could write that down right here. So this would have 3. So what in this case, I have an ite. -1 has 3, but I have an ite. So that's 2. And this will work with every single polyatomic ion that you ever needed to memorize, except the positive ammonium, but that one is very unique. So let me just show you one last one. Like if I had nitrate, without looking, let's figure this out. I have NO. What charge does that have? -1 or -2? So look at the first element. Say -1 or -2. So you got to figure out where it is first. It's going to be -1 because it's odd, right? Okay, so if it's -1, the 8 has 3. So this is NO. Is it 3? Like, what am I going to write? NO. Oh, shoot. Oh, we'll do that one. Actually, no, I did mean to do an 8 because that's different than this. This is an 8. It's -1, so it has 3. And I know you're maybe like, oh my gosh, this is like, I was hoping it would be a little easier. Well, you could memorize 11 completely different ions, or just start remembering, okay, 8's. -2 has the 4, and -1 has the 3. Bigger number, bigger number. Smaller number, smaller number. 2 to 4, 1 to 3. And it will slowly start to help you a little bit. Or, I can let my friend, we have a couple last little things to do yet. try to help you with that. So,
are we going to learn this? We all are going to sing a song. So, are you ready? Clap, clap, clap. Are you clapping with me? Come on, you need to clap with me. Clap, clap, clap. Clap, clap, clap. Itsy bitsy Spider-Man ate creamy cakes. Itsy bitsy Spider-Man ate creamy cakes. Topped with brown nuts, peaches he ate.
here, let me show you.
Topped with brown nuts, peaches he ate. Clap. Here we go. Which in this
Check this out. It's based on the vowels and the consonants. Watch this.
exactly one. So well, we got next set of polyatomic ions. Itsy bitsy Spider-Man ate creamy cakes. Itsy goes with IO3 -1, which is iodate, and Spider-Man, the spider goes with 2. Let's see how we got IO3 -1. Itsy has 3 consonants. That's what we got, 3 oxygen atoms. And it only has 1 vowel that goes with -1 as the charge. How about spider?
One more thing, I just want to show you.
got 1, 2, 3, and 4. 4 consonants. That's why we got O4 for sulfate. And we got 2 vowels. So that's -2. Let's find out the next 2.
So there you go. Itsy bitsy Spider-Man E8 creamy cakes.
Wait, you have to finish it.
You don't want to see this. So, down here on the website, please, last thing. And we forgot to show this to some of the other classes. I know a few of you, this has already been told to you once, but I want to illustrate this and show it to everybody. By Monday, you have a choice if you like. This is new. We've never offered this before. You can get some extra credit. I'm trying to get it all in one thing. If you can find, there's labels everywhere. It's amazing. All of a sudden you're sitting at the kitchen table and you have ketchup in front of you or syrup or whatever. And there you could be looking at a label. And if you see a label with a bunch of ingredients that use the nomenclature that we are using, so we're doing covalent, ionic, or acids, you could get some extra credit. But you got to understand how it's going to work. If you don't follow these rules, you won't get the points. So if you deviate from it, sorry. It's spelled out there for you. The link's been sent to you on those weekly chemistry weekly calendars, and it's online. So this one I found. This is like the first one I searched for. Now this is online. You got to actually have a real label. This has 9 compounds in it. They're all ionic, unfortunately. A couple little things so you understand, like ferrous and cupric. Those were some of the names that we learned in the beginning of the year of the actual names of like iron and copper. So if you feel like, well, yeah, that kind of looks like something I remember, and then it ends in sulfate. That's probably that's a polyatomic ion. It works. Here it is. If you find a label with 1 compound in it, you get 2 points. 2 compounds, 5. 3 compounds, 7. 5 or more, 10. I found 9 right there. And then the coup de grace, the biggest thing you could. If you find a compound, we haven't done acids yet, but you only need 3 ingredients. If one is a covalent compound, so it uses prefixes, one is an ionic compound, and one is an acid, a minimum of 1 of each, you get 15 points, which is just as much as an extra credit report. But it's got to be the naming that we do. So it can't be like highlight yellow 5 or something else. Like that's not like sucrose. That's not one of our things that we're naming. Here's how you get it. You need to cut it out somehow or have it on there, and either you can take a photo of it and maybe put in Notability and highlight it, or you actually literally highlight it, and somehow you need to get that into Canvas, either by taking a picture or scanning or something. You guys will be creative on that, and you got to bring it in. Or else what you could do is just pass that around, and everybody just has it, and somehow writes differently on it or makes it look different. You need to hand it in. Please don't ruin your parents' food. Like, don't cut out a big square on the side of something that has like powder falling out of it for the next month in their pantry. I don't want an entire bottle of Aunt Jemima syrup, even though it is not there. Because that's your family's food. Like, you may need to transfer that into something else. So, let's do by Monday. We're going to learn acid nomenclature, and that's fast. Don't worry about it, time-wise. We're going to learn about acids on Friday, but you have all weekend then as well, so you can start looking at labels at least and be like, well, you know what? I could use that one or this one. So you have to submit it, and you have to bring it in So start looking at labels. Never know. All right. I'll serenade you with crisscross. If we have 5